Jai to all. My name is Vaishali Deshwal and currently I'm working as an assistant professor at AKGEC. So this session is about blockchain architecture design. This is the very first session of blockchain architecture design. The code for this subject is BCS 063. So today in this session, we'll try to cover some concepts in Unit 1 and some basic concepts related to blockchain, which forms base for the further concepts. So the very first point talks about intro to blockchain, like what is digital money and what is the journey to move from digital money to the distributed ledgers. Then the second topic is about some design primitives. In design primitives, we have the 5 basic primitives like protocol, security, consensus, permissions, and privacy. Then we have blockchain architecture and design. So there is a proper architecture and some of the components. We'll be discussing about those, like basic crypto primitives, hash signatures, etc. So there are some concepts related to cryptography, hash chain to blockchain, and some basic mechanism. So in this, we'll see some basic or the list of consensus mechanism, and in Unit 2, we'll discuss those consensus mechanism in detail. So the very first concept is about the digital money from the physical one. So digital money is the money which is in the electronic form. And distributed ledger. Distributed ledger, in the layman language, ledger means record. So it is the same record shared across many computers. These are the basic terminologies which we will use later on while we will study the different concepts in blockchain. For example, distributed systems. Now blockchain connects these two, digital money and distributed ledger. Then we have some examples of these, like UPI is the example of digital money. Then bank server is the example of centralized ledger, and blockchain is something about the ledger copied on many computers. As we are talking about the distributed systems, we have the same copy on all the nodes, on all the computers. So there are many terminologies like Bitcoin, Hyperledger Fabric, or blockchain. So blockchain is a technology, and Bitcoin and Hyperledger Fabric, these are the platforms. So blockchain is not Bitcoin. It's a whole technology, and Bitcoin based on that. So blockchain is a technology and Bitcoin is one of the application of the platform. Then the question is, can blockchain exist without Bitcoin? So the answer is yes, because blockchain is a technology and we built Bitcoin or such applications on blockchain. Next is the basic definition or the factual information about the blockchain. So the very first point talks about a blockchain is a distributed database, means whatever database we are using here, it is distributed. It is not centralized at all. That maintains a continuously growing list of ordered record called blocks. So this is a very important term. We have number of blocks, and these blocks are quite interrelated to each other. So these are the number of blocks which are quite interrelated to each other. And that is why we know, we call this technology as blockchain technology. So a continuously growing list of ordered records called blocks, and these blocks are linked using cryptography. So we use several concepts here for the security purpose, and all these fall under the cryptography. I can name some. We use hashes, then we use digital signature. So all these concepts comes under this head, this cryptography head, and we use these concepts for the security purpose to link these blocks. So the second point talks about that each block contains a cryptographic hash of the previous block, a timestamp, and the transaction data. As you can see in this diagram, we have the blocks like block number n-1, then block n, and n+1. As you can see here, it's a ordered, the blocks are arranged in order. First we are having n-1, then n, then n+1, or you can simply say 1, 2, 3. So blocks are arranged in some ordered format. And then these are some of the components a block holds, like we have header, then we have previous block address, timestamp, nonce we have, and the Merkle root. So in each block stores previous block address. Means if we are talking about block n, so it will store the address of this previous block n-1, and this very block, that is block n+1, it stores the previous block address, means block n address in it, and that is how the blocks are quite interlinked together, okay, using hashing. So the second point says the same thing, that it contains a cryptographic hash of the previous block, and that is the main reason, or you can say that is how they are interrelated to each other, the blocks, or that is how a chain is formed. So the third point talks about a blockchain is a decentralized, distributed, public digital ledger. Obviously it is a ledger, it's a record, it is we are storing the set of transactions on the ledger, and we have so many terminologies which helps us to decide that who will write the next page of ledger. For that we have some consensus mechanism, but two important things we need to remember, that a blockchain is a decentralized and distributed system, okay, and it is used to record transactions across many computers, so that the records, they cannot be altered, they cannot be changed. Once you're done with the storage part, it cannot be changed without the alteration of all the subsequent blocks, and also the consensus or the agreement of the network. Now the next point says that it's a list of record called blocks that stores data publicly and in the chronological order. So in the diagram it is very much clear that all the blocks, they are in the chronological order, and blockchain, it is storing the transactions, or it is a set of records called blocks. Next point talks about that the information is encrypted using cryptography that ensures the privacy of the users. So here we use the concept of digital signature for or to provide the several features like data integrity, data authentication, and non-repudiation also. So in this we use digital signature, a concept of cryptography, to ensure the privacy of user is not compromised at all, or the data cannot be altered. That is what we meant by data integrity. Means whatever data you are providing or whatever data is provided by the sender, it is same throughout the process, or in the transit it remains same, and the same data is received by the receiver. So that is the data integrity. Okay, and the last point is, or the second last says, it's an expanding list of cryptographically signed and irrevocable transactional records. Means you cannot revoke those records, and all the records or all sort of messages, all sort of transactions you're talking about, they're cryptographically signed. Means you are using the digital signature concepts. So we have a concept of keys, private key and the public key in digital signatures shared by all the participants in the network. So each record contains a timestamp and the reference link. Now it is again very important here. Each block has a timestamp component in it. As you can see here, this is the timestamp. So every time when a transaction comes, time is recorded. So with this information, anyone with the access right can track back a transactional event at any point in its history belonging to any participants. A blockchain is one architectural design of the broader concept of the distributed ledger. So the main head is the distributed ledger, and under this we have this blockchain architecture design in it. We have these concepts like timestamp and the reference link, so that every block is interlinked together, and anyone with access right can just trace back a transactional event, because every time when a transaction is recorded, time is also recorded at the same moment. And that is how you are maintaining the chronological order. Okay, now a blockchain is distributed. It's a database or a ledger that stores the information, and the information is transactions. Whatever transactions you're storing in a database, that is the data for blockchain in a data structure called blocks. So here the block serves as a data structure because you're storing the transactions in block. It is based on distributed ledger technology, which can be used between the parties that don't trust each other. So it is a very wonderful feature of blockchain that there are so many nodes in a network. There's so many parties in the network, and they are just in a competition to that who will write the next page of the ledger, and they are in agreement even if they don't trust each other. That is only because of the some key concepts we have in blockchain. For example, consensus mechanism. So it is based on distributed ledger. It is because when you add anything onto the blockchain, it requires verification. And as we are having the blockchain is working on decentralization, so you have, or you can say that every node has power to decide or to verify that whether a transaction has to be added onto the blockchain or not. So it requires verification from all the other users available on the network. Now, blockchain keeps information permanently in the uniformly sized block. So there are the blocks, and the block size is uniform. Okay, where each block stores the hash information from the previous block. So if this block is 1, this block is 2, this block is 3, and they are interlinked together. How they are interlinked? Because this block 2 storing the information or storing the hash value of this particular block. Now this third block, it stores the hash value of this particular block second, and this is how a chain forms using the hashes of the previous block. Okay, now there are many hashing algorithms you can count. So here we are discussing this SHA-256 hashing algorithm, and as we are aware that the hash functions are one way, means they don't have that encryption or decryption process in them. They are used for the verification purpose, means, or you can say they are only for the validation purpose. You cannot extract the same message from the hashed function again as we can do in the decryption process. So if we take the scenario of digital signature, there if you have a message, you are encrypting it, you are converting into hash, and then you are encrypting it, sending it to the receiver. Then at the receiver end, he used the public key to decipher that message, and that is how you are able to extract the same message from the after applying the decryption process. But this is not the case with hash functions, as they are the one-way functions, means they are used for the encrypted purpose. The message is converted into the hash function, the fixed size function, and at the end you are able to verify that whether there is any discrepancy in the transit with the message or not, but you are not able to extract the original message from the hash value, and that is why we are saying that it is one-way hash function. So in hash function, or the hash information is simply the data and a digital signature from the previous block. So two things the hash function contains. Now the hashes of the previous blocks that go back to the very first block produced in the blockchain are known as the genesis block. So, or simply you can say the genesis block are the blocks which are very first in the blockchain. So they don't have any hash value, that is automatically set to the 0. And a blockchain data structure is in the form of Merkle tree. So here we have the concept of Merkle tree, or specifically we can say we have a concept of Merkle root. Merkle root has a set of all transactions in it, which is used as an efficient way to verify data. So we'll discuss that how Merkle tree is responsible, or how it is the process of verifying the process. What is Merkle tree? Okay. So we have discussed this blockchain structures. We have blocks that are associated with each other through or by storing the hash value of the previous block. We have these much components in a block, like header contains metadata, you can say, because all the information, it is not feasible to store all the information all the time. So it has this metadata, then previous block address, it stores the hash value of this block, it stores the hash value of the previous, that is the block n, then it has its timestamp. Nonce is a random number, and we'll discuss nonce in detail later on, but for now you can understand it as that nonce is a random number. It is used by the miners while designing the puzzle problems for the consensus. Like if you use POW, a consensus mechanism, then in that you have to design some sort of problems. So for designing the problems, you can use this nonce value, a random number. And then we have Merkle root. We'll discuss Merkle root later on, that what is Merkle root and what is the Merkle tree. Okay. Okay, so quickly we'll discuss that how does blockchain works. So blockchain is a combination of three important technologies. First is the cryptographic keys. In this you can have private key or public key. Then we have peer-to-peer network. This peer-to-peer network is responsible for having the decentralized network as we have in the blockchain. And then the digital ledger, that is simply the record. So cryptographic key, each individual of the node has both of these keys, private key or the public key, and they are used to create the digital signatures. Very specifically, we can say that sender uses private key to decrypt the data, and receiver can decrypt the same message using public key of sender. And that is how you are maintaining data integrity, data authentication, and non-repudiation sort of properties by using this digital signatures. So digital signature is unique and secure digital identity reference. Every transaction is authorized by digital signature of the owner. So now peer-to-peer network we are talking about, that it forms a very important or the core component of blockchain. So it can be described as a large group of individuals or the nodes who act as an authorities to reach an agreement. Consensus is an agreement, and it is quite indispensable to reach an agreement or a consensus in order to validate that which transaction will be added onto the blockchain or not. So all of these transactions are stored in a structure called digital ledger. So this is the structure we have, or we can say digital ledger works like a spreadsheet containing all the numerous nodes in the network. Now the information contained in the digital ledger is highly secure, and the digital signature safeguard is from being tampered with. We have already discussed these things, that the security is maintained using some cryptographic concepts. We are using hash, we are using digital signatures, and that is why we are saying that the transactions which are contained in the digital ledger is highly secure. So there are the minimal chances of the tampering. And the most important part is that anyone can see the data, but no one is able to tamper that or corrupt that data. Okay. So the following is a list of the most important features, the core features of blockchain technology that set it apart from its competitors. And we have the whole list, like decentralized model, transparency, persistency, open source autonomy, anonymity, immutability, and auditability. So this is it for today. We'll discuss these features, the core features of blockchain, in the next session. And in this lecture, we have covered some of the basic concepts related to blockchain. The core concepts like decentralization, distributed, immutability, hash values, how the blocks are formed and associate or interlinked together. So in the next lecture, we'll discuss all these things, the features of blockchain.